All right, so this is what we're going to be looking at together in class today. So this is our EDSB page for fourth period, but it'll look the same for fifth and sixth. So we've got this our last day of practice on completing the square. And so you will have some video notes tonight. You'll see the homework there. Watch the 3 videos and complete the guided. I added an extra E on guided apparently. Notes to on the quadratic formula. My dog is snoring next to me. Stop. All right. So we've got this worksheet then is what we're working on today. And as you see back here, it says we're going to work on the odds. So we'll do a few of the evens together just so we can kind of be clear on what we're looking at and how to do them. Come on, open up. There we go. So you guys are going to be doing the odds. So there's about 10 problems there. I shouldn't say about, it is 10 problems. So we'll do some of these together on this side so that we can kind of make sure that we're clear on how this all should look. And if you notice, and I got this message from someone earlier saying, you know you left the answer key on there, and the answer to that is yes, I know I left the answer key on there, because what I want to see from you when you submit it, and I haven't put the assignment up yet, I realize, but I will right after this, or even maybe while you're working, I'll put it on there, is that what I want to see is your work, okay? So this will allow you to know that you've done your work properly. So if you don't get 4 and -6 for your answer on number 1, you'll want to go back and check your steps. Okay, if you don't get 5 and 3 on number 3, go back and check your steps. If you don't get, you know, on number 13, 10 plus or minus the square root of 70 over 5, you'll want to go back and check your steps. Okay, so that's why the answer key is there, is so that you can check your work, or at least your answers, and that way you'll know that you've done it properly if you get to that answer, okay? So let's do a couple of these together then today. Let's see, I think I saw a hand go up. Let me see if that hand is still there. Open the screen up a little bit. We got quite a few people in today, so appreciate that. All right, so Jaden has his hand up. Jaden, what's up?
Are we doing like all odds or all evens or all of them?
You guys are going to be working on odds. We're just going to do a couple of sample problems from the evens so that everybody's sure on how to do those, especially these with the, like we'll look at number 12 first, and then we'll do a couple of those that have these numbers on the front end, so we can make sure everybody knows how to deal with those, right? But yeah, you guys are going to be doing odds for the practice action.
Okay, thank you.
You're welcome. All right, let me get a couple more people from the waiting room in here. And let's see if I got any other hands. So, all right, it doesn't look like we have any other hands. So what I'm gonna, well, one more from the waiting room. Let's get that person in. All right, so what I'm gonna do here, let me just copy one of these problems, and we'll put it on our whiteboard and work from that format. Right. So we're just going to copy this problem, number 12, and I'll put it on the whiteboard here. And I will share the whiteboard with you. All right. So let's switch screens that I'm sharing. So we'll go over here to the whiteboard and work on that. All right. So we have this problem. This is number 12 from the sheet. So you may have some other problems similar to this as you go down the odds. So first thing I want to do with any problem that is not already in standard form, meaning that it's not equal to 0, unless it's a whole number value over here. If it's any type of variable term, I need to move that to the other side. If it's a whole number value, I can probably deal with that okay without worrying about it, and we'll look at a problem like that. But if it's a variable term, I definitely need to move it to the other side. All right, so first thing I'm going to do is add this 4n squared to both sides, and I can only add n squared to n squared. So I'm going to add it there, and negative 3n squared plus 4n squared is just n squared, right? Plus 4n minus 59. Now this does equal 0, so we're in standard form for that quadratic equation. So what I want to do is make sure that this doesn't have any coefficients, which it doesn't, and I want to clear this out so that I can complete the square, create a perfect square trinomial. So the next step is I'm going to add 59 to clear that final term out. So I get plus 4n, and over here is 59. Notice I'm leaving this space so that I can complete the square, complete that perfect square trinomial. So what I need to do now to complete the perfect square trinomial is take half of this middle term and square it. So half of this middle term is 4, or the middle term is 4, so half of it is 2. And I'm going to square that and add it to both sides. Okay, this side I'm just going to leave unsimplified because it's going to help me in my factoring of that. This side I'm going to simplify. So this side over here, 59, that's going to become 4. And so this side becomes 63. Over here, this is going to factor down into its binomial format, which again, if you recall, right, this is the perfect square trinomial of something that is a squared binomial. Well, the first term is going to be the n. Second term is actually going to be the 2 that I found. This middle, or the sign comes from that middle term. So if this was negative 4n, I would put a minus here. But since it's plus 4n, I'm going to put a plus there. Okay. Now I'm going to take the square root of both sides at this point. And so this side, I would get n, just the n plus 2, right? The square root just cancels that square. Over here, I get 2 solution possibilities of positive and negative square root of 63. Square root of 63 doesn't simplify to a number completely. Let me just check and see if they actually simplified the square root on this one. Yes, they did. So this goes back to simplifying square roots a bit. So I want you guys to kind of go back a few units ago where we were simplifying square roots. So when we were simplifying square root of 63, right, it's not a perfect square, but it has a perfect square factor. So square root of 63 can be broken into a perfect square factor of 9 from here, right? Square root of 9 times square root of 7, okay? So I can actually simplify this to 3 times the square root of 7, right? Because that becomes 3 when I take the square root of 9, actually. All right, so hopefully that's ringing some bells about looking for the perfect square factors when simplifying an irrational square root. So technically this becomes positive and negative 3 times the square root of 7. And then this is still equal to n plus 2. So if I subtract 2 from both sides, I still can't subtract the 2 from that, okay? This is still an irrational number, even though it's now got this number that's a rational multiplier, a rational factor of this number. I can't subtract 2 from that 3 because this 3, order of operations would say I would do the 3 times that and then add or subtract whatever this is. So I'll just come over here and say that my answer is n equals -2 plus or minus 3 times the square root of 7. Let me just make sure that my work matches my answer key there. And if we, let me just switch screens again back to this. So if we look at what I had for my answer of -2 plus or minus 3 times the square root of 7, they wrote it as two separate. -2 plus 3 times the square root of 7 and -2 minus 3 times the square root of 7. If you wrote it like I wrote it, that's fine. So like up here on number 6, you should get 2 plus or minus the square root of 95 for your answer if you go through that process correctly. All right, any questions on that particular problem or just the method in general? I know this is about the third day we've worked on completing the square. So do you have any questions still lingering at this point on, let me go back to my work here, on any of these steps, especially this new introduction of, not necessarily new, it's just a reintroduction of simplifying a radical? Any questions at all? All right, so let's clear, actually one hand going up here. Jaden, I'll get to you here. All right, Jaden, what's up?
Do you always have to do that thing you did with 63, like to simplify it?
It depends on the number. Obviously, 63 has a perfect square, but like, for example, like if this had been square root of 62 instead, probably wouldn't have been able to do that because there's no perfect square factor of 62. So it's only things that can simplify as a radical that you would want to do that for. So if you get down there and you see, oh, well, like if you had put -2 plus or minus the square root of 63, and then you look at the answer key and you see that there's some simplified radical there, probably just means that you forgot to simplify the radical. All right.
Do you ever simplify 63 or like just take it out of the radical completely?
Well, remember the 63 can break into these two factors of 9 and 7, right? When I do that, the only part that comes out of the radical is the 3. The 7 stays in because I can't do anything more with it, right? So, for example, let me go back over to the answer key for a second so we can kind of look at the answer key together, and I can probably point out the ones that will simplify for you. So you guys are doing odds, right? So obviously that one gives you integer values, 3, 5, 7. You see how in 12 there was a 3 in front of the radical, right? So this part of it right here, that indicate to you that that's a simplified radical. On number 7, you see how 89 doesn't have a number in front of it, like right in front of the radical anyway. That means it's not going to simplify. All right, so I don't think actually looking at any of these, it's a possibility that 15 or 13 might have some simplification, but I'd actually have to look at the work to tell you that. But most of these look like they don't have anything that would have a simplified radical like what well, number 9 will.
Okay.
Because it's got that 2 in front of the 3. So that was probably the square root of 12 is my guess at some point. Okay. All right. Good question. Thank you. Any other questions regarding that particular problem? Mia's got her hand up. Good morning, Mia. What's up?
Yeah, for number 11.
Yeah.
So, on the other side, do you see how it's 2 plus x? I don't understand what you do with the x.
You would need to, in the same way I added this 4n squared on the 12, right? You would need to subtract the x from that 15x, right?
Okay.
Subtract it. So actually, let's do number 18 because it's kind of got a similar situation. So let me just copy that real quick, and then we'll do that one together before we break into our groups here.
Okay, thank you.
Go to clear this off on our whiteboard real quick. Paste it on this problem. All right, that's a weird one. I don't know why I did that. That's weird. I'm just going to write this problem down. I think it's doing something weird on my whiteboard. I'm sorry. I'll show you what it is here. So it's 9a squared minus 21 equals 13a. So let me get that off here, and then I will share this screen back with you. Well, that's not working at all. Sorry about this. Technical difficulties. Right, I don't know why that's there. I'm just going to get it off the side here. All right, so switch screens here for you. Back to our whiteboard. Sorry about that. Okay, so to Mia's question, what happens if we've got like just an A or an X in the case of the problem she's looking at? We would need to move it to the other side. So in this case, I want to subtract the 13A and subtract the 13A. Well, there's no A term on this left side, so it's just going to kind of slot in the middle there. So I'm going to get 9a squared minus 13a minus 21 equals now 0. Okay. So for your problem, Mia, that you were asking about, you would subtract the x from the 15x and just be left with a 14x on the left side when you do that. So now this is the other type of problem I wanted to take a look at, because quite a few, and why we're doing this extra day of practice on this, is when you have these that have the first term's coefficient, something other than 1. All right, so you're going to have a few of these on your work, as you can see, where that first term coefficient is something other than 1, and it may not divide out completely. So first thing I want to do is get rid of that. If it's got that first term coefficient, I don't want it there. So I'm just going to divide everything by that number, including this side. Technically, so I get a squared, that's the point. I want that just to be an a squared, an x squared, whatever the variable is. This is going to leave me a weird fraction, okay? And this is a good problem to show because of this weird fraction. And over here, this simplifies slightly, but I don't want to simplify that right now because it's going to be easier actually to leave it all with the same denominator for the moment. So even though it simplifies, they both have a 3. I don't want to simplify that fraction right now. Okay, so I'm just going to leave that as 21/9, and this side is still just 0. Okay, so I want to clear off this side because 21/9 is not a perfect square. So I'm going to add 21/9 to both sides. All right, and if you're using fractions or decimals here, you're going to get repeating decimals, and you don't really want that. So as much as I know some of you don't like dealing with the fractions, it's actually an easier thing in this situation than having repeating decimals all over the place. So this becomes 21/9, right? So let me move this up a little bit so we have some more room. All right, has anybody got any questions at this point? All we've done so far is just get rid of that first term coefficient and then move this fraction to the other side, clear that off. Okay, so the second part, or the next part of this, is to get half of this term. Well, this is a weird number to begin with because it's already a fraction and they're both odd numbers. So how do I divide that by 2? Okay, that becomes the question. Well, when you have a fraction that's there, anytime you generate a fraction, once you divide by this number, because a lot of times you're going to generate a fraction for this middle term unless it divides evenly. You need to then, instead of saying I'm going to divide by 2, you want to actually multiply by 1/2. That's going to take half of the amount, in the same way dividing by 2 would take half of the amount, okay? So please make sure that you are using that method. Let me just check. Somebody sent me a chat message. Let me see if I can see it here. For some reason, it's not popping up. Where my chat screen went. Let's see. All right. If you sent me a chat message, maybe try sending it again, because it didn't populate for me for some reason. Okay, so we're going to take half of this term. Again, easiest way to do that is to multiply it by half instead of dividing by 2. So 13 over 9 times 1/2 really is just 13/18. Okay, so I need to add 13/18 squared to both sides. Okay, this is going to be a ridiculously weird fraction problem when we are done with it. Okay, so let me just, because I don't know off the top of my head what 18 squared is, so I'm just break out my calculator here. So 18 squared is 324. So technically what I am adding to this side, right, is also 13/18 squared. Okay, so this side, as I begin to simplify it, is 21/9 still. This side, 13 squared is 169. 18 squared, as I said, is 324. Okay, so now I need to create a common multiple on the bottom, a common denominator, so that I can add 21/9 to 169 324ths. Again, all very weird numbers. And if you're using decimals here, you're going to get, again, a bunch of repeating decimals. The easiest way to figure out what you're going to multiply this fraction by, right? I want to multiply this fraction now by something to make it into a 324th. Easiest way to figure out what you need to multiply 9 by is take that 324 and divide it by 9, okay? Because it came from a 9th over here, right? It was originally a 9th. In this case, it became an 18th, and then we squared it to become a 324th. So 324 is going to be divisible by 9. And so what it's divisible by, 324 divided by 9, is 36. So what I need to multiply this fraction by is some form of that fraction, 36 over 36. Okay? Please give me a hand at some point if I've lost you, all right? Because there's a lot of fraction work going on here that I want to make sure you guys are following. Is everybody following me at this point, or did I lose anyone along the way? Right, I don't see any hands. Okay, so I'm going to multiply this 21/9 by this form of 1 so that I get a common factor of 324. All right, so I know that my bottom number is going to be 324. 21 times 6 on the, or times 36 on the top is 756. All right, so this, when I multiply by that number, okay, is 756 over, whoops, I'm running out of space again. Let me move this up. Okay, so I get 756 over 324 plus still that 169 over 324. All right, so 756 plus the 169 is 925. All right, so I get this really weird fraction down here. All right, so that's my fraction. Now, I have to take eventually a square root of this. So let me just switch over to my scientific calculator on my phone there. So first, before I do that, let me factor this side down because that's what I need to factor down. So this side I'm going to factor down to a, right? It's into its binomial format. So a from there, 13/18 from there. And here is my sign. So it's minus, okay? So this problem. Then we're going to take the square root at this point, right? And the square root here. Now, the square root of 925 does not exist. It's not a perfect square. However, it ends in 25. So that is a possibility as far as one factor that could come out of it and be a perfect square. So that's what I'm going to break this number into once I begin to simplify. So first thing here, this side, I'm just going to get a minus 13/18. And this side, I know that the 324 came from squaring 18. So 324, if I'm just taking the square root on the bottom instead of on the top as well, if I just break this into, right, we can remember that if I take the square root of a fraction, I can take just the square root of the top and the square root of the bottom separately. So the bottom will actually simplify back down to 18. And don't forget that this is a plus and minus of that. All right. Now, as I said, this isn't a perfect square. So I can't take the square root of 925 without getting some irrational number. But I can simplify the radical a little bit because of the 25 that's a factor of this. So if I do 25 at the top, I got to figure out what 25, if I divide 925 by 25, I get, I believe it was 37. Let me just double check on my calculator here. Yeah, it's 37. So that is the top number. And then this is the 18. So this actually can simplify to, one more time, to 5 times the square root of 37 over 18. Right? These things, if they were divisible, could actually simplify in this fraction because one's rational, this is rational, this is rational, but 5 is not a factor of 18, so that won't simplify. So let me just come down here and rewrite this now that I've simplified this side completely and say a over or minus 13/18 equals positive and negative 5 times the square root of 37 over 18. All right, a lot of fraction work, a lot of steps in this. All right, so I think once we finish doing this problem, you're going to appreciate what we are going to do tonight on your videos or this afternoon on your videos. That will make this process so much faster for you. But let's finish this process out, and that is to add 13/18. Okay, these both have an 18th, so we can just add 13/18 to both sides. All right, that 13 is the rational number, completely rational. It's going to go in the front of that plus minus. So I get a equals 13 plus or minus 5 times the square root of 37 over 18. Now let's see if that is actually correct. Did I not make any mistakes? This will be an amazing day in my life if that happened. Oh my gosh, it worked. So obviously, if you look at that answer there, 18, if you look at the answer key, and I'll show you the answer key here real quick. If you look at the answer key, that's probably the hardest problem on this sheet. So if you didn't completely follow everything I just did, that's okay. I just did the hardest problem on the sheet for you and with you. So I think the only problem that may rival that in terms of possible difficulty might be number 13. So when we break into groups here, if you want to start at those problems, say 13 and 15, that might be something I would do in your group then. All right. Any questions before we break into groups? I'm going to try and visit everybody as we do this. Any questions at all for the whole group? All right, so let's clear that off and we will set up, let's see, we've got about 30 some participants in here right now. So I'm going to break into about 5 rooms, I believe. Maybe 4. Looks like we're getting some people dropping off to work on their own. So we'll do, let's say 4 rooms. And we'll just let it do automatically. So I'll jump around if you need me to, want you to move around. Let me know, send me a message, and I'll try and move you to a different room if you have someone you want to work with.
Hi, Mr. Peters.
I'm jumping in here first because I know that the first question out of Brooke's mouth is, does anyone understand this?
You didn't hear that. You didn't hear it.
Was
No,
that the first
okay. I think I understand it, but like, some of it is confusing.
I know some of it is. That's why I said.
Mr. Peters, I did the other
Right.
worksheet all on my own, and I got them right. And then my group even said I was wrong, and they all got the same answer. And guess who actually got it right? I did.
Sure it
Thank
was
you. You taught me well. You taught me well.
I did.
Thank you.
One student.
Thank you.
So what problem are you on now? Have you started working on any of these?
No, but I want to know like 11 because do I have to move the X and then do I move the 2?
You don't necessarily have to move the 2 because eventually you're going to move that 15 anyway.
So just don't even worry about the 2, just move the 15.
Yeah.
Okay, then I think I'm good.
All right.
Is it okay if I do it on a separate sheet of paper?
Yeah.
Okay. Thank you.
Uh-huh. All right, I'm going to go jump around to some other rooms. If anybody in here needs me, just give me a shout.
Okay, bye.
Okay.
Shelby, are you there? Hold on, Bryson. Did I not assign you to a room? Let me see. Let's see. All right, I don't see the person you asked for is still on. I think he may have dropped off to work on his own. So Bryce, I'm just going to unmute you for a second so we can have a chat. Let me move this here. So Bryson, it looks like there are still 3 rooms open. So room 1 has Cameron, Donovan, Emily, Kyla. Room 2 is August, John, Ben, Jules, and Maya. Room 3 is Brooke, Chase, Evan, and Jonna. Any fun in any of that?
Can I please join room 2?
1 or 2?
Yeah,
Is that
the one with the August in it.
August? Okay, and that's room 2. So let me move you, or assign you actually. So move to room 2. All right. So you should be able to join that now. Let me go here real quick. Hey, Elijah. Looks like your room became empty. Elijah,
Yep, everybody just left.
all right. You want me to move you to a different room then, where there's actually people?
Sure, I will very much appreciate that.
All right, so let's see. Here's room 1 has Cameron, Donovan, Emily, and Kyla.
All right.
3 appears to be the only other one open now. Brooke, Chase, Evan, and Jonna.
All right.
Do you have a preference on those 2 rooms?
Can I go into room 3?
Sure. Let's see. Move to room 3. All right. How's it going here?
Good. Oh, Cameron's audio doesn't work, so she's trying to ask us questions through Word document.
Oh, okay.
I spelled my name right.
Okay. 12, I don't get, but number 3, I'm not on 12 yet, but number 3, you you get, your first step would be x to the power 2 minus 8x plus 4 to the power 2 equals negative 15x plus 16. And then you would simplify that further, and you would get x to the power of 2 minus 8x plus 4 to the power of 2 equals 1. And then you would put those in radicals.
After you factor.
It wouldn't be minus 16 because it's a negative 15 and a positive 16, because negative 4 to the power of squared is 16, and it's positive. And it's a negative 15 because it was plus 15 originally. And then you would put those in radicals, and it would be 5 and 3. No problem.
All right. Go into another room. Just if you need some help, let me know.
Mr. Peters, we have a question on number 9.
Okay.
So, because n to the second isn't with negative 14 and 37. So would you subtract n to the second and move it to the other side?
I mean, that would maybe make sense, except that then it becomes a negative n to the second.
So would you
that term to be negative?
just,
So
well, could you like switch the sign? So like you divide it by the negative and then switch all the signs?
yeah, you could do that. Or
Is that what you're supposed to
you
do?
could just move the other two to the other side and change their signs also. So like n squared plus 14n plus 37.
Okay. And then it'll just equal 0 and then you do it like a normal problem?
Yep.
Okay, thank you.
Uh-huh. Chase, how are you?
I'm doing good.
Okay. Evan and Elijah, you guys doing all right too?
Yeah.
Is 1 a square root? Just like, is there a square root of 1? Like 1 times 1? Would that be a
Yes.
square root?
Yes, it is a perfect square.
So you can take the square root off of it, so it's just 1?
Well, if you're taking the square root of 1, you would get 1 and negative 1.
Well, yeah, but just,
But yes.
okay, thank you.
All right. Apparently there are only 2 rooms open at this point, so I'm just going to jump back to the other room real quick. Give me a shout if you need help.
Thank you.
Okay, I got the right answer.
Didn't, and I don't know what I did wrong.
Okay, do you
So-
mind turning on your camera so I can see your work?
Yeah, wait, one sec.
I'll turn on mine too.
How do I? Okay, I'm just gonna try to share it with you. Want us to mute ourselves?
No, that's fine.
Okay.
All right, so let me share this screen. All right, so this is number 13, is that right?
Yeah.
Yeah.
Okay, so from here, right, now is where you need to complete the square. So I think Emily said it at some point that you're going to take half of this and square it. So half of that is 2. Right, so you're going to add 2 squared to that side. So you get negative 6 over 5 plus 4, right? Technically 4 over 1. So you need a common denominator in order to add those. So that means you got to multiply this one, this whole number, by the denominator of that one to get the common denominator. All right, following that?
Yeah.
Yeah.
So we get negative 6 fifths plus 20 fifths. And then this is 14 fifths. And then over here, right, we're going to factor this to its binomial format. So n, and then the 2, and then the subtraction sign from that middle term is that. So this is where we got to take the square root.
How do you take the square root of 14 fifths? Do you take the square root of 14 and the square root of 5? But I don't think those work. Yeah, 14 doesn't work.
Neither of them simplify. So you would just wind up with
14 fifths.
square root of 14 fifths when you take the square root of that side, and this side when you take the
So you
square
have to plus 2.
Yeah, you have to add the 2.
is n minus 2.
So it'd be n equals plus positive 2. No, it would be negative 2. What?
No,
Yeah.
be positive.
No, it would be a negative because once you square it, it becomes a positive.
Oh, I know why the answer is different on 13 than what we're going to get here.
Why?
Because they rationalize the denominator. So we will be okay leaving this answer, at least in my. So I'll show you what they actually did, but technically you're going to add 2 to both sides, right? So
Yeah.
equal 2 plus or minus the square root of 14 fifths.
So you'll take that answer?
Yeah. So what they actually did and why they're showing that is normally this would be written like this. Like if this was, like if I truly cared about the format of this answer, it would look like this. So we don't want that answer. So what they did is they just changed this to, they multiplied both of these by 5 in here and got the square root of 70 over the square root of 25, which then, so if you look at the answer key, it has that square root of 70 in it, right? So that's where that comes from. They tried to rationalize that denominator on the bottom by
For
multiplying.
15, will you let us do the same if it sells different or whatever?
Yeah, that's fine.
Okay.
Can you do number 15? Because
Can I do number 15? My office hours, because it's now 1:02.
Well, that's okay. You could do one more.
I don't know about that.
I promise. I'll allow it.
All right, so here's what I'm going to do. I'm going to stop the recording.
Okay.
And because you guys stayed and actually worked, I'm going to do that one for you, but no one else on the YouTube will get the answer.
Yay.
Yay.
All right, so
Wait, we're
let
the only people that stayed?
Wait, really?
hold on. I
Did
believe
they
you
all
were
just leave?
I think you were the only people still in this Zoom meeting. So I'm actually back to this. I'm going to stop sharing that for a second. Let me just see. I don't think there's anybody else. Oh, actually, Brooke and Chase and Elijah. I'm going to put everybody back into the main room so we can all
Okay.
Okay.
Thank you.
Thank you.
Thank you.
Let me just go over there and tell them what we're doing. Okay, so guys, real quick, it's past 1 o'clock, but here's what I'm going to do. The other room asked if I could do number 15 with them. Since you guys have all stayed and worked, I'm going to put us all back in the main room. I'm going to do that one for you guys, and I'm going to stop the recording, okay?
Okay, thank you.
Okay.
Put everybody back in the
Mr.
main
Peters,
room.
I have
We'll
a
do that
question
one
on
together.
13 really quickly though.
Yeah, I think I'll be able to answer that once we go back together. So
Okay.
I'll close these rooms, and I'll see you all back in the main room.